And hello all to a final thing. Oh, actually, this is in the textbook, so that's wrong. It is in the textbook. I'm sorry I don't have the lesson in front of me, but the page coming up will tell you where the homework assignment is, where it is in the textbook. Measuring composite figures, compound, multiple figures put together in one. Keep that in mind. Now, I did promise that I would ask for some questions in Monday's lesson. So if you have any questions, make sure you bring them to the Google Meet. And here is Tuesday's lesson if you would like to pause. No, excuse me. This was Friday's. If you'd like to pause, come on back when you're ready. All right. So this was the old teacher's bell work, but it seems like a perfect transition into where we're heading. So I want you to think about what kind of figures would be found, what kind of area, what kind of volume would be found if you drew some figures that needed the following formulas to do so. So if you'd like to pause, come on back when you're ready. If we have length times width, that is a rectangle. If we are subtracting or getting rid of pi r squared, you could imagine some circle that we don't want. So perhaps you drew a figure like this. Now, if you have a better understanding of the directions, pause, come on back when you're ready. Pi radius squared height sounds like a cylinder. 1/3 of a cylinder sounds like a cone. And if we are adding them up, so that was a little, I don't know, I guess you could call it a preview of where we're going. Our goal today is to measure a composite figure in terms of a two-dimensional area or a three-dimensional volume. We're going to take everything we've learned from measurement and move into some more challenging composite figures. Pause, come on back when you're ready. So this is the page. Forgive me for not knowing what section in the book it is. But I'm going to actually do, before I even get into notes, I'm going to give a number of shapes. And so I think what I'll do is I'll do this 3, 4, maybe even 5, 6 times. Every time I show you a new shape, go ahead and feel free to pause the video, decide what 2 three-dimensional figures would be needed, or if there's more than 2, you're welcome to that. And then decide if you should add or subtract their volumes. For instance, I see 2 rectangular prisms. Perhaps I cut it here. You can either draw or write those words, and then the key is to add, though, right? By the way, there's more than one way to do this problem. You could have done it like this, but it would still be the addition of 2 rectangular prisms. So that's the directions. You're going to either draw out or write out the words and then put a plus or a minus in front of them. Again, maybe you'd like one more example. Otherwise, pause, come on back when you're ready. What 2 shapes? Well, on the left, I see a cone. On the right, I see a cone. And if we want the total shaded volume, you guessed it, we would add. Now, of course, our homework assignment is actually going to get into the formulas and find the volumes and add them up. But we're doing okay with that. We just need to see what 2 or more figures that you see and decide if the volume should be added or subtracted. So if you'd like, pause now. Come on back when you're ready. The larger shape on the bottom, I start with the biggest for whatever reason. The larger shape on the bottom is a prism. It's a rectangular prism, as is the one on top. And you guessed it, we would want to add these together. Pause, come on back when you're ready. Larger shape, cylinder. Smaller shape on top, cone. Yeah, we kind of already did that one. But this is a common shape of a silo that's used to hold grain on farms. All right, what about this one? This one is not the best of pictures. It's supposed to be it's almost like a pipe. So I'm going to go ahead and shade in what would be shaded in if I could get a crayon here. So imagine that pipe being kind of hollow, if you will. All right, so decide how much plastic or metal would be needed for that volume of the pipe. Pause, come on back when you're ready. Now, if you can imagine the solid pipe before a hole was drilled into it, it'd be a cylinder, right? But now look at the part in the middle that you don't want. That's another cylinder. And oh, by the way, because we don't want it, we would subtract that inner part to find the total volume of plastic that we would need to melt and shape to make the pipe. You would take the large exterior cylinder like it was not hollow, and then you would subtract the inner cylinder. All right, how about this one? This one usually trips people up, so pause, come on back when you're ready. Naturally, that bigger shape is a prism. To be precise, it is a rectangular prism. How about this top shape? If you said pyramid, you would not be correct. This is a prism, but it's a triangular prism. So imagine the two bases, and if you want, when you get to your homework, you can always color those bases in. And it's surrounded by a few rectangles. All right, now if we wanted to heat the entire barn or building, we would have to add together the volume of those two prisms. I'll tell you again, the tougher part was always triangular prisms. All right, how about this? You're looking at a ball that's packaged inside a cube box. Find the air surrounding the ball. In other words, you want all the air that is kind of wasted space inside the packaging. Pause, come on back when you're ready. So if you think about the larger figure, which is a cube box, because it sure looks like the ball touches all the walls. Oh, it even says touches the walls. And the ball, of course, is a sphere. Now, if you don't want the ball, if you only want the air surrounding it, you would subtract the volume of that sphere. And by the way, this might seem obvious. If that 8 is a diameter, the radius of it would be 4. And all the measurements of the cube, if the ball touches the walls, would be 8 inches across. All right, ladies and gents, back to our homework page. So I'm actually going to do a few of these problems with you. I kind of combined the directions. So you are either finding the area or the volume of each shaded region, each shaded space figure. Sorry about number 4. I couldn't figure out how to shade that one well. And by the way, yeah, let's cross this off. We are not using 3 and 1400s. You guys know that. All right. So if you want to get ahead of me, you're welcome to pause and do the same thing we just did. Come on back when you're ready. So what I see in number 1 is I see a circle, and then inside of a circle, I see a square. And oh, by the way, we don't want that white region, so we're going to subtract. That to me is the most important part. Now, I already know the formula for the area of a circle. I already know the formula for the area of a square, and I know to subtract. So let's talk the circle. Appears to have a radius of 10 inches, pi times 10 squared. Let's talk the square. The square appears to have a side length of 4 inches. And so what I'm going to do, I'm not even going to figure out, in the old days before we had better calculators, you would find this guy, you would find this guy, and then you would subtract them. We don't have to do that because we have our nice Desmos calculators. Ooh, wish I wouldn't have just deleted that. So you can type this whole representation in. It would always help to have good number sense, I will say. So 10 squared is 100, 100 times 3 is 300, 300 minus 16, probably 280-ish, right? So now we go ahead, we type it in, and we get an answer of 298. And there are parts, pieces, portions, which of course we're going to round to the nearest hundredths. I don't think the textbook says that because they want you to use pi or 3.14. We're not going to do it. Closest to 1600 square inches. I will try to remember to fix up the answer sheet to say that. All right, onward. Number 4, definitely see a cylinder. And then I see what looks to be a rectangular prism. And because we don't want, if you look in your textbook, you'll notice that the entire exterior is shaded except for this interior part, which seems hollow. We don't want it. We're going to subtract. Now, that doesn't mean that every problem in this assignment is a subtraction problem, but in this case, it is. So now we'll go ahead and say, all right, to find the volume of any cylinder, you take a circle and you stack it up h units tall. To find the volume of any rectangular prism, you multiply length, width, and height. And as we already said, we're going to subtract these two quantities. Now, if I look carefully, whoops, don't forget that second power. If I look carefully, it appears that this guy has a radius of 10 inches and a height of 15 inches. So 10 times 10 times 15 times pi. But don't calculate it yet. We can do the whole thing together. If I look carefully at this rectangular prism with units 4 by 4 by, well, wait a second, there's no number by it, but it's the same as the height of the cylinder. 4 by 4 by 15. So go ahead and subtract those. And as long as I push things into the calculator correctly, you're going to get about 4,552.38898, yada, 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 which is going to be about 4,552 and 39 hundredths. Ah, shucks. Trying to squeeze in the cubic units here. So you can see kind of the algorithm, the step-by-step process of finding any of these regions or space figures. Find one shape, find another shape, and frankly, there might be more than two sometime. Just decide, do you need both of those shapes? If so, add them together. And if you don't need one of the shapes, if you want to take it away, then go ahead and subtract it. All right, ladies and gents, that's what I got. Do well. Quiz coming. See ya.